Hey guys, so we're going to go over the logarithmic parent function, and this one is a new function that we're going to be learning over here in Algebra 2, and I'll give you guys some more information about it, but just kind of want to go over the parent function first before we start going into transformations and anything else. But this is the logarithmic parent function once again, and this is what it looks like. So this is f of x is equal to log of x. Now there's a couple of things that I want you guys to keep in mind. Now, there's a base of 10 whenever it's not written. So for example, here it would be log base 10 of x. So whenever it's not written, it's always assumed that it's a base 10. If it's any other base, it's always going to be written. It's kind of like the square root. Let's say, for instance, the square root of x. There's really a 2 here when it's the square root. Whenever it's like the cube root, of course, we write it here, or maybe the 10th root, we write it here. So this is the same thing with the square root. The 2 is not written, but it's assumed that there's a 2 there. So it's assumed that there's a 10 here whenever it's written like that. So it's log base 10 of x. Another thing that I want you guys to know is that you're not multiplying log times x. It's log of x. So a lot of times you'll see parentheses here and sometimes you won't. But if there's no parentheses, there's an assumption that it's going to be parentheses here, it's going to be log of x. And I'll give you guys examples where the parentheses are super important. Okay, now here's I plugged in some numbers into this function and I put them ahead of time. So I plugged in 0.1, 0.5, 1, 2, 3, and 4 into x, and what it gave me back is all these y values here. So what I'm going to do is I'm going to graph them so you guys can see what the parent function, which is this one, looks like on the graph. Okay, so if I were to plot this one here, let's go to, because I know I'm going to do 4 on the x-axis, so it's going to be 1, 2, 3, 4. And then if I plug in 0.1, it's going to be super close to the origin, and then I'm going to go down 1. And if you notice here, the lowest we're going to go is 1, so I'm going to put a 1 here, -1. So I'm going to go over 0.1 and then down 1. So that's the first one there. Okay, the next one is 0.5. When I plug in 0.5, I'm going to get a -0.3. So 0.3 is less than half, but more than a quarter. So it's about there. Okay. The other one is 1, 0. So that's where it crosses the x-axis. The other one's 2.3. So I'm going to go over 2, up 0.3. Let's say this is 1. So 0.3 is about here. And then 0.3 and up 0.5. So 0.5 is right in the middle. And then I'm going to go over 4 and up 0.6. And just to kind of let you know, these I rounded off to the nearest tenth, okay? So if you were to plug these into the calculator, you're going to get them rounded off on my end, okay? So if we were to trace this, it's going to look something like this. So it's kind of curving out, okay? So here's the logarithmic parent function for log base 10 of x, okay? Now, some of the things that I want you guys to keep in mind is the domain, range, and all these other attributes that are associated to it, because it's going to come into play whenever we're using these functions to solve equations, okay? So the domain, all the x values that this function takes. So notice how it doesn't cross this y-axis, and that y-axis is at 0 on the x. So it doesn't go to the left forever, it actually stops. And there's actually an imaginary line here that's called a vertical asymptote. And I put a dotted line to denote that it's a vertical asymptote, a VA. Okay, so it doesn't go past that and doesn't even touch that line. So the boundary is 0, but it doesn't include 0. So I'm going to put parenthesis so that I don't include 0, and it goes to the right forever. So it's going to be all the way to infinity. So from 0 to infinity, not including 0. Another way of writing this is x is greater than 0. So anything greater than 0 is the domain. Okay, for the range, this one you're asking how low, how far down does it go, and how high does it go? So in this case, it goes down forever, and this one actually goes up forever, but it just goes up very gradually. So it's going to go up, but it's going to be super slow, much slower than it goes down. But nonetheless, it's still going to be all real numbers. So this is the symbol for all real numbers, or we can write -infinity to positive infinity, okay? Now the end behavior, this is what's going on the tail ends. Like what is it doing if you go to the left forever? What is the y value doing as you go to the right forever? Now, as we're going to the right forever, which this is what it means, as you're going to the right forever, which is all the positive numbers, is the y value going up? Are we going down, or are we flattening out? Now, This one, I know there's a common misconception that this kind of looks like it's flattening out. It is going up forever, just super slow. So as we're going to the right forever, our y value, which is called f of x, is going up, all the positive numbers, okay? Now for the end behavior, for going to the left, I would put, as we're going to the left, I would put negative infinity here. However, we're not going forever. We're stopping. We have a stopping point, and that stopping point on the x-axis is 0. So as we're approaching 0, as we're getting to closer and closer to 0, what is the y value doing? Are we going down? Are we going up? Or are we flattening out? Now you can clearly see we're going down forever. So I'm going to put the y value goes down forever, so it's negative infinity, okay? The x-intercept here, whenever we're doing the x-intercept, is just basically where we're crossing the x-axis. So we're crossing the x-axis at x equals 1, okay? So this is happening at x equals 1. Sorry, 1, not 0. And the point is going to be 1, 0. So that's the x-intercept, okay? The asymptotes, I just told you earlier before, we have several different types of asymptotes, but in this case, we have a vertical asymptote only. Now, the equation to this one is super important. Now, a lot of times we're used to seeing a vertical line and thinking, you know, y-axis, but the equation actually to this one is x equals 0. And the reason it's x equals to 0, it doesn't matter where you're at, anywhere on this line, your y value, your x value is always crossing 0 here. So if you're to graph this here, it's going to be a vertical line. So at x equals 0, okay? Now, I didn't want to just kind of continue on with this one and just, you know, kind of, I want you guys to know where this one relates to, what other function it relates to. And it relates to this exponential function. Notice how it has a base 10 and this one has a base 10. Well, it turns out these are inverses of each other. Now, if functions are inverses of each other, there's really different ways of analyzing it. In this case, I want to analyze it on a table and a graph. So if it's inverses, there's this imaginary line that's called y equals x, this dotted line here, y equals x, that if it's reflecting off this line, then that means this other graph here that's reflecting is an inverse to this one. So these are inverses of each other. Now, if on a table, if they're inverses of each other, that means that the x and the y value are flipping. So I want you guys to take a look at this graph for 10 to the x, which I'm telling you all that it is the inverse of this one, but I want you to see it on a table and a graph, okay? So since I'm already telling you that it's an inverse, that means that if I were to use these table values to help me find the inverse, that means that you flip them. So this is now going to be your x values, and these are now going to be your y values. So this is going to be -1 here. This is going to be -0.3. This is going to be 0, 0.3, 0.5, 0.6. And this is going to be 0.1, 0.5, 0, 1, not 0, 1, 2, 3, and 4. Okay, so this one corresponds with that one with this one. Did I mess up here somewhere? I missed a number, I believe. So -0.3, 0, 0.3, 0.5, 0.6. Okay, 0.1, 0.5, 1, 2, 3, 4. So these are all corresponding to each other, right? So if you notice here, these are reflected, or these are switched up, your x and y, and the x and y values are flipped here. So let's go ahead and graph it. So -1 on your x-axis is going to be here, and it's telling us we're going to go up 0.1. So if this is 1, 0.1 is going to be super close here, okay? And if I plot -0.3, well, -0.3 is about 1/3 to the left, and I'm going to go up half. So this is half of the y value there, that's a 1. Here it's going to be 0, and we're going to go up 1. And here it's going to be, we're going to go to the right 0.3, and we're going to go up 2. So it's right here. And this one's going to go to the right 2, and we're going to go, we're going to go 0.5. So 0.5 here, and we're going to go up 3. Okay, so this is more a little bit here. We're going to go to the right 0.6, so it's going to be here, and we're going to go up 4. So it's going to be about right here. So notice here when we trace along this line, we have that exponential function, right? And notice the relationship between this one and this one. I was mentioning how if it's an inverse, it's going to reflect off this y equals x, and it does. This one does reflect off this y equals x. right? So y equals x. So that means that this function here, which is the logarithmic function, which is log base 10 of x, is an inverse of this one, 10 to the x. Okay, so these are inverses of each other. But let's take a look at the domain. So if they're inverses of each other, that means that the domain and range over here are going to be flipped on this side. So let's take a look at it. So the domain for this function here, we're going to the left forever, and we are going to the right forever is just going to be kind of gradual. So this one is going to go up forever, little by little, but it's going to go to the right forever. So this one's also all real numbers, or we can write negative infinity to positive infinity, okay? The range, the lowest point that it goes is 0. It doesn't cross this line, which is on the y-axis. This right here is 0, but it does go up forever. So the way we would write that is parenthesis, because we're not including 0, because this graph doesn't touch the x-axis, but we are going up forever, okay? Another way to writing this is we can say y, in this case, y is greater than 0. So if you notice, these two are flipped. So the domain here is now the range over here, and the range here is now the domain over here. So it is flipped. So the end behavior, here we're going to analyze it as we're going to the right forever, which is as x goes to positive infinity is to the right. What is this one doing? Is it going up? Is it going down? Or is it flattening out? Well, in this case, f of x is going up forever, so positive infinity. So f of x is your y value. Here, as we're going to the left forever, notice how it doesn't stop, it doesn't have a boundary. As we're going to the left forever, which is negative infinity, our y value, which is an f of x, it actually it starts flattening out, right? So it starts flattening out to this line, which on this line here, that y value is 0. So it starts approaching 0. Now you kind of start seeing how this is kind of flipped. Notice how this top line is this one here, and this one over here, as we're, these ones are being flipped as we're going to negative infinity, our y value is now approaching 0, right? So it's flipped here because they're inverses. Now for this one, the asymptote in this case, it has a horizontal asymptote. This is an HA, and our horizontal asymptote formula is y equals 0. So that's that imaginary line that this function approaches, okay? All right, so I wanted to jump into just one example here of what this looks like if it wasn't a base of 10. This is base of 3. So I plugged in the values already. I plugged in 0.1, 0.5, 1, 2, 3, and 4, and I ended up getting these values. Once again, I rounded off to the nearest 10th. So if we take a look at this portion here and graph it, so we're going to go over 0.1 to the right. So that's 1. We're going to go down negative 0.21. So this is 1, 2, and here's going to be 0.1, and we're going to go a little bit below that. That's negative 0.21. Here, if I go halfway, 0.5, I'm going to go down 0.6. So it's going to be here and a little bit more. So I'm going to go half of it. Here, it's going to be 1, 0, so I'm going to graph it here. Here, we're going to go over 2, and I'm going to go up 0.6. Okay, we're going to go over 3 and up 1. So over 3, up 1. Here, I'm going to go over 4 and up 1.3. So it's about here. So if I graph this, it has the same shape as the parent function. However, it's being stretched a little bit more, so that base does have an effect on it. So it's not how quickly it's increasing is a difference maker here with the bases, okay? So this is what the graph looks like. So the domain is very similar. Actually, it's identical to this one. So the domain for this one here, as we can't go to the left forever, we're bounded by this line, and that's 0. So not including 0. And we're going to go all the way to the right forever, so all the way to infinity. So this is the range, this is the gap right here that we're talking about the domain to be. The range itself, it goes down forever and it goes up forever. It just goes up gradually. So we're going to say all real numbers, or we're going to say negative infinity to positive infinity. And just to kind of give you an idea, this one can be written as x is greater than 0, okay? The end behavior is pretty similar to this one as well. So as x is going to the right forever, so as x approaches infinity, our y value, which is f of x, well, that one's shooting up as well. So it's going to go up forever. Here, we're bounded. We can't go to the left forever, but we are bounded by 0. So as we're getting closer to 0, what is our y value doing? Well, that one's shooting down forever. So it's going to be negative infinity since we're going down. Our x-intercept, this one it's going to be the same as the other one. It's going to cross it at x equals 1 or 0, 1. And then our asymptote is going to be this imaginary line that we have here. So this is your vertical asymptote. It gets closer and closer to that line, and the equation to that one is x equals 0. Stay tuned for some more videos.